Hello and welcome. My name is Shiki and today we're going to continue the Path to DevOps series. We're going to run the Barbart stack of applications on our host but using containers. And you'll see how easy that is compared to running all three applications, mapping them to ports. If you don't know about containers, then check out my previous video, which will be linked at the end of this video. And if my message caught your attention, then let's jump right into the action. There are two necessary things for you to follow along in this tutorial, and both of them will be linked down in the description. The first one is obviously the source code, which can be found in my GitHub account, and the second one is a container engine. And I honestly recommend Rancher Desktop because I don't want to bother myself with the licensing model of Docker. So if you feel like me, then you'll find the link for Rancher Desktop in the description. If not, just make sure you download whatever container engine you desire. Last time, when we ran all three applications locally, but manually, we had to go through several steps. The first one was to compile all three applications. Then we had to configure them to each its own port. Then we had to actually tell the front end how to find the backends. And finally, we ran all three applications and we were able to obtain the website, which was running perfectly. Now, today, we're going to have to go through the same steps, but containers are going to help us out a lot. So let me show you exactly how. If you remember from the Docker crash course video, which is somewhere on this channel, and if you don't, check it out, there are three stages to a container's lifecycle. The first one obviously being the Dockerfile, which is a set of human readable instructions that the Docker engine will parse in order to create the image. Well, you won't be surprised to find out that I already prepared the Docker file for each of these applications, and you can check it out by opening the folder, and there you have it, Docker file. Now, this is not a simple Docker file because we have actually two images that are being created. The first one is called the builder, and its sole purpose is to compile the application, the Java application, and then it will pass its jar onto the second image, which will actually be our runtime, the image we want in order to run the application with it. The same Docker file that is in cart API can be found in product API. They're basically identical. And then it's a different one for frontend because there are different technologies and different steps in compilation, but the idea is the same. The first one is the builder and the second one is the actual runtime. For the sake of simplicity, I have already opened three terminals here on my bottom right side. And you can see that each terminal has the name of the folder it's actually inside of. Let's build those images. Let's start with cart API, and the first command will be docker build dot for the local folder. And then -t for tag, and I'm going to say barbart / cart API 0.1, and I'll just copy it so that I don't have to type it again, and then I'm going to hit enter. And while this is working, I'm going to switch to the product one, and I'm just going to change, it's the same command. I'm just going to change the name of the image that's getting created. And this one started as well. And then front end. And there we have it. Now the whole compilation process is going on for us behind the scenes. And all we had to do is run one simple command. And what's even more fascinating about this is that anyone can run this command. So maybe in order to compile the application, you need specific skills and you needed to know what technologies to use in order to compile either Java or the Angular front end. Well, now all you need to know is how to build a Docker image, and it's fairly simple. Docker build and then the current folder.
A few moments later.
Having built all 3 Docker images, the next step is to run them as containers. And what better way to achieve that than using docker-comose? Because docker-comose is a tool that's specifically designed to run multi-container applications. Exactly our scenario. You can find the docker-compose file here in the GitHub repo. And it's basically a YAML declaration of what we want to achieve. I want 3 services. One is called product API, one cart API, and one frontend. I have the images declared here for each of them, a restart policy, and the port mapping to our host. Also, the backends need some environment variables to connect successfully to the database. In order to bring all of this up, all I need to do is open another terminal, or I could have used one of the other existing ones, but I chose to open a new one, and do docker-compose up. This is going to create a network for my services and then add the services into that network for them to communicate with one another and start them up. One eternity later. Now that all 3 containers have started, let's look at them with the docker ps command. And as you can see here, we have 3 containers up for roughly 40 seconds. Now let's browse to the application so we can check it out in our browser. And I'm going to hit localhost 9090. And as you can see here, we have the full functionality of the website. But we didn't only expose the front end. We can also browse to localhost 8080/product. And we're getting the JSON data from the database. Or we can browse to localhost 8081/cart. And we should be getting the message that's printed on the screen when we action the buy now button. Now we have the full functionality of the 3 applications running on our machine. But for this, we've used containers, and in my opinion, it was a lot easier because we only used like 3 commands in order to bring everything up and running. And what's even easier is to take them down. We just go back to the terminal we started them in and we Control-C. And now all 3 containers are being stopped. Aside from managing all 3 containers with one single YAML file, which is pretty powerful in itself, it's even better that most of the process of compiling the applications was automated. And that's the beauty of using containers. Now, using containers, we've automated a good chunk of the whole compilation process and even running of the applications. But we're DevOps, we're not satisfied with this. We want a fully automated process, and we also want to run our applications somewhere that they're publicly accessible, because so far we've only ran them locally on our machine and no one from the internet could access them. Well, in the future videos of this series, we're going to do just that. We're going to move the applications into a pipeline process that deploys them into publicly available cloud infrastructure. If that sounds fun, then follow along and I'll see you in the next video. Cheers!